On this one, on 23, what page? Good question. So, on this particular part, we had a worksheet that I gave you guys a few days ago where I had 2x to the something equal 18 or something like that, where we divided by 2 first. On this particular problem, the difference is the 6 inside the grouping symbol with the x, or is it outside the grouping symbol? Inside. So do you divide by 6 first? No. That comes after. Good. On the worksheet that we had, there was no grouping symbol, so therefore we should have divided by 2 first and then done what we were going to do. Okay? Now, something else that happened yesterday with some of your classmates. Some of you were trying to rewrite that as the cube root of 6x squared and trying to get rid of it that way. Don't. That's making more work for you. In order to get rid of fractional exponents, you multiply it by its reciprocal. What is the reciprocal of 2/3? 3/2. Good. Or 3/2, whichever way you want to say that. When you multiply reciprocals together, that gives you one big giant 1. So that's 6x now on the left side. Now, here comes the next part that people messed up with. 36 to the 2/3 is not 54. That's 36 times 2/3, not 36 raised to the 2/3. 36 raised to the 2/3 power can be done simply by typing it in your calculator. If you're going to do it with an older 83, make sure that the fraction, Luke, goes in parentheses. If you didn't, I would take the square root of 36, which is 6, and 6 to the 3rd power is 216. And then how do I solve for x? Divide by 6, and 216 divided by 6 is 36.
How do you do that power real quick? How do you do that?
How did I do the way I did it in my head?
Yeah.
Okay. This number right there, remember, is the number that goes in the square root crack. Okay? So because it's a 2, Nick, it's like saying the square root of 36 and then to the 3rd power. Nick, what's the square root of 36? And then I got 6 to the 3rd. That's how I got the 216. Okay? I know what 6 to the 3rd power is, but if you didn't, your calculator would. Okay? What do you think? Not too terrible? All right. Then on to 24. 5, the square root of x plus 2 is greater than 17. Quick question for you. What's the difference between this problem and the last 3 we just did? It's an inequality. How do you solve inequalities differently than equations? What's the difference between the two? Besides it being an inequality versus an equation, is there anything that I do differently? Isaac?
All right, if you divide by a negative number,
Okay, what up?
it flips the sign.
Okay, is that what you're going to say, Vanessa? Okay, good.
Is it divided?
If you multiply or divide by a negative number, you must flip the symbol. Is there anything else? Or is that the only thing that matters? Okay, we'll see. So if I were to solve for x, how do I do that? Subtract 2. What's 17 minus a deuce? Then what? Divide by 5. What's 15 divided by 5? 3. Then what? Square both sides. And I get x is greater than or equal to? 9er. Awesome. Done, right? What do you mean no? Why? Okay. Brianna's saying something up here like she said no, and I said, what do you mean no? And she said, well, you got to do something with x is greater than 0. Where is that coming from? Under the radical symbol. That's the difference. Not only is what Isaac and Vanessa were going to say by multiplying or dividing by a negative, you must flip your symbol, but also you got to check the restriction. That's the biggest thing that people forget. Remember, you're not allowed to square root negatives. Now, that's saying x is greater than 9, and Brianne said that it should be x is greater than 0 for that restriction. Why the 0, by the way? Okay, you cannot square root negatives, but why 0? Huh? I can't hear you. When you look at just the square root of x, it's just 0. There's no number attached with it, right? Underneath there. So that would have to be greater than 0. But, real quick, we're not starting this till we get above 9. So therefore, do I have to list that extra restriction of x is greater than 0? No. Because the x is greater than 9 picks up that. So I don't need that on this problem. 25. What's the first step in solving for x? Divide everything by 2. What is 24 divided by 2? 12. Now what? Square both sides, because you're getting rid of the square root. So you square both sides, not square root it, like some people were saying. You square both to get rid of the square root. Therefore, you square root when you're getting rid of square. Okay? On the left-hand side, I get x minus 8. On the right-hand side, what is 12 squared? 144. And then what? Add 8. What's 144 plus 8? Now, yesterday I had a number of people ask me this question, not necessarily in this hour, but the other two. They were, that can't be right. We can't have it 152. That's too big. Who said? Who said it was too big? Can you have big numbers? Yeah. You're just not used to them, so you think that you did something wrong. When you didn't. You did everything right, but your answer's wrong. Why is your answer wrong? It has everything to do with what Brianne said on the last problem. If you said x is less than 152, you're saying that everything to the left of 152 works. No. Where should it stop at? It should stop at 8. Why 8 and not 0? What you do is you put the inside stuff equal to 0 and solve for it. So x minus 8 equals 0. X would equal 8. That's your stopper. Because if I put 0 in there, I'd be square rooting negative 8. You can't do that. So can you square root 0 though? Yeah, so therefore that would be an equal to. So one of the two options I'm going to give you for this is if you write the answer like this, where you have x is greater than or equal to 8, and the two different parts like that, I will take it. Or if you put it as 1 like that. Either way, to me, that says the same thing. Because if you cover up one side versus the other, you're saying here x is less than 152. And when you cover up this side, you're saying x is greater than 8. So you're saying both. If you write them as two separate ones, that's okay. Okay? What do you think? Do you understand the difference between the two? Okay. On 26, it's got 7, the cube root of x minus 3 greater than or equal to 21. Before I start, is there a restriction when it's cube root? Can you cube root negatives? Yes, you can. You can cube root negatives. So therefore, is there a restriction like we had on the last problem? No. No restriction. So solve for x. What do you do? Divide by 7. What's 21 divided by 7?
3.
Cube it. And what is 3 cubed?
27.
Then what? What's 27 plus 3? 30. So far, so good? Okay. So again, what I just talked about on the test for tomorrow is going to be like ones for, that could be for the adding and subtracting ones, or the equal ones could be 1, 2, 5, 6, and 7. That's it. Then on 27, it says, in a tsunami, the wave speeds in meters per second can be modeled by S for speed equals the square root of 9.8 times D, where D is the depth in meters of the water. Estimate the depth of the water when the wave speed is 200. All I did was I put 200 in for S. Let's solve for the D. How do I do that? How do I solve for D? Huh? Square both sides. 200 squared is 40,000. 9.8 D. Now what? Divide by 9.8 to both sides, and when you get the D, how much did you get?
4,000.
Roughly, right? It was a rounded answer. Thanks, Haley. 4,082, which means in a tsunami, if the waves are going 200 meters per second, there are roughly 4,100 of these stacked on top of each other high wave coming at you. To keep this as a perspective for you, rough measurement, this is about 2.5 from floor to ceiling. So that's only 2.5 as the wave coming at you. Imagine 4,100 of these coming at you. That's a really big wave. I do not want to see that in my life. Okay? 28 and 29. 28 and 29, we're performing the function operations. 28 and 29 are just like numbers 3 and 4 on your assignment or your test tomorrow. Okay? They are heavy questions because they're asking you to do multiple parts. When you look at 28, it says, let f of x be equal to the square root of 3 minus x, and g of x for the cube root of 3 minus x. And what we need to find is we need to find f times g. We need to find f divided by g. We need to find their domains. And we need to know what happens when we plug in the number 2. So how many pieces am I asking you to actually find? 6. I'm asking you to find 2 equations, 2 domains, and then 2 numbers when you plug it in. Okay? Now, on this particular problem, the setup I don't necessarily care for. So what I'm going to do is I'm going to rewrite the function to make it look more like fractional notation. So that's the same as 2 parentheses 3 minus x to the half. How did I get the half there? How can I go from square root to a half? Let's try this. What if I change this one then, and this one would be 1/3? How did I get it to be 1/3? I put what under 1? Point to it. Because I know you're having trouble figuring out where it is, but point to what told me the 3 went on the bottom.
No. Yeah? Okay.
Okay? Vanessa pointed right here. That's where she pointed. That number that's in the crack of the radical goes in the bottom of the fraction. If there's no number, it's understood to be a 2. There is a reason why I did that. When I multiply the two pieces together, 2 times 3 minus x to the half times 4, 3 minus x to the 1/3. If I did this problem up on the board here, if I change this to 2y to the half and times 4y to the third, first thing that you would do is multiply the outside pieces together. What's 2 times 4? 8. And when the bases are the same, you add the exponents. That's the rule. So on this one, we added it to make it 5, 6. Are the bases the same? Yeah. It's both 3 minus x. So since what was underneath the house was exactly the same, I am now going to add the exponents. In order to add fractions, you need to get a common denominator. What's a common denominator between a half and a third? 6. So what's 3/6 plus 2/6? 5/6. That's the combination of f times g. Now let's take a look at the domains. Anytime you have domain restrictions is when you either have A, square root in play, or B, fraction in play. Did we initially have a square root in one of the fractions? Or one of the functions, I mean. Yes, we did. What number would make that equal to 0? If it's 3 minus x on the inside, what number gives me 0? 3. Now, Courtney, good job correcting your answer. Courtney, do numbers to the left of 3 or to the right of 3 work on the number line?
To the right.
What number is to the right of 3? 4. Courtney, if I put 4 back into this problem, what's 3 minus 4? Can I square root negatives?
To the left.
It's to the left of 3. Good job. So that means that x would have to be to the left of 3, or less than or equal to 3. That's my domain. Here's the nice thing, you guys. If you have the domain for the first one, what should the domain be for the second one? What? What'd you say? No. Same. I couldn't remember if you said that or not.
She said everything.
Oh, okay. Now, if I plug in the number 2, what's 3 minus 2? 1. What's 1 to the 5/6 power? 1. What's 1 times 8? 8. Now let's find the dividing. I take 2, 3 minus x to the third, or to the half, sorry, divided by 4, 3 minus x to the third. First with the numbers. 2 over 4. Does 2 over 4 reduce to what? 1/2. Good. Are the bases the same? Yes. So then you see who has more. Is half bigger than a third? Yes. By how much? One sixth. Good job, Nick. Now, the last part when we multiplied them, we added them, and you got 3/6 and 2/6. You got them in the same bases, or same exponents, right? Or same bottoms. So then if you're looking at who has more, you compare 3/6 on the top as compared to 2/6 on the bottom. Remember, you subtract them. 3 minus 2 is 1. Now, if I plug in the number 2, what's 3 minus 2? 1. What's 1 to the 1/6 power? 1. What's 1 times 1? Divided by 2? 1/2. Let's say that models number 3. you need all 6 parts for number 3. You need the equation, you need the domain, and you need when you plug the number in. And you're going to have to do that for the adding and the multiplying and dividing. Yes, Paige?
Can you explain again how you got 1/6 in
For the exponent? When you have 2 or 1/2, that's the same as 3/6. And when you have 1/3 on the bottom, that's the same as 2/6. I'm getting them to be the same denominator so I can compare which one has more. 3 of them on the top as compared to 2 of them on the bottom. The top has more by how much? You subtract. Right. Good job. I'm glad that you had that aha moment. That's awesome. Okay, so that's number 28. 29. The F machine is 3x squared plus 1, and the G machine is x plus 4. First, find F plus G. Second one, find F minus G. Domains. And then when we plug in the number -5. This one's different than the last one. What am I asking you to do when I'm asking you to add? Good. Isaac, how many squareds are there up there? Yep, so it's 3x squared. Awesome. How many x's do you have, Isaac? Just 1. Now, Isaac, here comes the $1 million question. What's 1 plus 4? 5. Good, Isaac. What's the domain? What's the domain? All real numbers. There is no restriction for this because A, there's no square root, and B, there was no fraction. This is a parabola. Right? Okay, good. Now if I plug in -5, 3 times -5 squared plus -5 plus 5. What's -5 squared? (25 times 3). 75 minus 5 plus 5. What is it? 75 minus 5 was 70, and then 70 plus 5 was, and that part's done. Now here's the part that most people messed up on for this. When you subtract, I'm going to suggest, and even if you're adding, I would suggest put it in parentheses. The reason why is because of signs. If I didn't put that second one, for instance, in parentheses, some people screw up the sign. They get the -x part, but not the rest of it. Again, as Isaac said on the first one, Sean, when I have 3x squared and there's no other squareds there, what's my squared term? Huh? What's 3x squared plus nothing? Yeah, good. Clay, what's the x term? Close. Devin, help your friend out. No, Devin, you can say it yourself. No. I don't know if you saw my hint, but you see how I have this like coming from this negative sign and then going to the x? Do you know what it is now? Yay! -x. Okay? Now here comes the part that a lot of people will mess up. If you didn't have the parentheses around it, here comes the screw up. This says 1 minus 4. What's 1 minus 4? -3. Some people on that one still had 5. Because if they didn't put the parentheses around it, they still considered it to be plus 4. Okay? What's the domain? Again, we're still just a parabola. If I plug in negative 5, I have 3 times negative 5 squared minus negative 5 minus 3. Negative 5 squared, as Tara said in the last one, was 25. Then I think Vanessa or Courtney, one of the two, said 3 times 25 is 75. 75 minus a negative 5 is what?
Wait, what did you say?
75 minus a negative 5. 80 minus 7. Or 3, I mean. 77. So, Luke, for instance, that's what you missed from section 3. Make sense? That is just like 3 and 4 on your test. So up until this point, there's 9 questions on your test, and I just talked through 7 of them. Number 30 on your assignment, and through 33, is identical directions to number 8. And for this part, it says, find the inverse, then graph both equations. How do you find the inverse? Swap x and y. Then what? Solve for y. How do I do that? Subtract 10. How do I get rid of a times by negative 1/2? Multiply it by negative 2 or divide it by negative 1/2, but at the same time it's easier to multiply by negative 2. If I multiply by negative 2, make sure that you multiply each piece by negative 2 and not just one or the other. That's my inverse. Number 8, find the inverse, sketch the graph of both. That's just like it. Can you sketch the graphs? Can you physically put it in your graphing calculator to figure out what it looks like? I hope so. Number 9, guess what number 9's like? Yeah, like 36. It's like a word problem.
Out in the corner. That's okay.
31, last one I'll try to fit in before we run out of time. How do I find the inverse? How do I make it equal to y? What do I do first? Subtract 8. Square root it. Now, typically speaking, when I square root that, I should get plus or minus. But on this one, and this is important, it has a restriction on it saying x is greater than or equal to 0. So when you're graphing that, if you were to graph both of them, that's not the equation of the original one. Because it only said x is greater than 0. It did not say this side. That's the original one. And the other one should come down in here, something like that. When you're graphing inverses, they should reflect over that line, y equals x. That's what should happen. 9 questions. 1, 2 says solve the equation, check for solutions. 5, 6, and 7, solve the equation or inequality, check for solutions. 3 and 4, add, subtract, multiply, divide. Domains, plug in a number. Number 8, find the inverse. Sketch both graphs. Number 9, word problem.